In this video, we'll look at how to graph the sinusoid y equals 4 sine of 2x minus 180 plus 1. Now you'll notice that we're in degrees, and we also use the variable x instead of theta. And we'll also notice, first thing, that my b is not factored out. Notice here that the variable theta has a 1 coefficient, and in this case x has a coefficient of 2. So the very first thing that you want to do is factor b out of this quantity. So let's do that. We have y equals 4 sine, and then I know that my b is 2 here, because when I pull that 2 out, then I'll have x by itself. So 2 times the quantity, x minus. Now you have to also factor it out of this term as well. So we divide the 180 by 2, and we'll get 90 degrees left inside the parentheses. You can check yourself by distributing the 2 back in there to see if you do get this term. And then we have plus 1. Alright, now to do our graphing, let's first find our amplitude. And my amplitude is the absolute value of A, which in our case is 4. Our next thing, we want our B value, which indicates the period of our sinusoid. And we have a formula that we need to memorize when we want to find period. Period, when we're in degrees, is 360 divided by b. If we were working in radians, it would be 2 pi divided by b. So for our problem, the period is 360 divided by 2, which is 180 degrees. Now at this point, what I usually do is calculate how many degrees in each section. Now remember, when we graphed our basic sine curve, we had each of the quadrants marked off. And this was 90 and 180 and 270 and 360. So these are our quadrantal angles, are the angles that are on the axes. And then our sine curve started at the origin and hits the max at 90, hits the center line at 180, hits the min at 270, and the center line at 360. So our basic sine curve looks like this. We need to keep the basic sine curve. We'll just be doing some translating and moving it around and so forth. But what I call a section is like this part right here. So from the number of degrees where it starts the period to the maximum, that would be one section. So we need to take our 180 and divide it by 4 to see how many degrees in each section. So we would have 45 degrees per section. And that'll help us in our labeling then. Our next thing is our phase shift. So we have a phase shift of C, which in our case is right 90. And remember, that is just opposite of what you would think, since this is a minus 90. We just grabbed the 90 there. If this had been a plus sign, then we would have had to change that to minus a negative. Then our next thing is D, which is our vertical shift. And we can see from our equation that is up 1 or plus 1. Now this vertical shift is where our center line is going to be. So I'll just make a note of that here. And this right 90 is our start. Alright, we have a lot going on here, so I'm going to start drawing my graph. Here's my x-axis. I need an amplitude of 4, and I'm doing a vertical shift 1, so I'm going to notch kind of small here so I can fit this all on my graph. My center line is at positive 1, so this dotted line represents my center line. Then my amplitude is 4, which means I need to go up 4 from my center line. So there's 1, 2, 3, 4. And this is going to be my max. And these are just guidelines, but I find that they're very helpful until you really get good at this. And I'm still needing guidelines to help me. Then my minimum guideline is going to be 4 down from the center line. So there's 1, 2, 3, 4. And this is my min. Okay. Now the values that we need to label here, 1 plus 4, this would be 5. And then 1 minus 4, this would be negative 3. So that's our labels there. Now, since I need 45 degrees per section, I'm going to start right 90, but I'm going to mark off 45 degrees on my axis so that I can have notches indicating every section. So we have 45, and I'm going to stop the recording here so that you don't have to watch me label everything. Okay, so I have everything labeled. I'm going to start at positive 90 degrees, so I'm going to start there. The usual sine curve starts on the x-axis, but since I shifted my graph up 1, I'll be starting at the center line. So I'll put my initial point right there at the center line at 90 degrees. Now every section, so this first section I go from the center line to the maximum. And every section is 45 degrees in width. So on the next 45 degrees here at 135, I need to hit my maximum, which is up here at this guideline. And then the next section, I go from the max to the center line. So this section then will be right here. And then for my next section, I go from the center line down to the min. So I need to hit my minimum at 225. And then hit the center line at the next one, and so forth. So these guidelines you can see are really helpful. Depending upon how much you want to graph, let's go ahead and continue left here. This is one section. I've already done my max here, my center line, so I need a min at 45. And then I need my center line here at 0. Now be very, very careful that you don't skip this, because oftentimes, since we don't have it labeled, students will skip that y-axis. And then I need a max at negative 45, center line, min, center line, max, center line. So this is plenty. Now we just connect the dots. Now make sure your sine curve stays between that max and min guideline. So you don't want to get up above that. So it fluctuates between And until you, unless you have a little bit of artistic talent, which I don't think I do, this curve may turn out to be a bit pointy or lopsided like this one is. But